Hello everyone, I welcome you on my channel Engineering Mathematics DJ Ganit. In this lecture we are going to discuss two more examples on system of linear equations. So let us start with example number 1. What conditions must B1, B2 and B3 satisfy in order for the system of equations to be consistent? So here we are given system of three linear equations in three variables x1, x2 and x3, and the constants on the right hand side are not given. They are unknown constants b1, b2 and b3. So we are asked to find out that under which conditions on this b1, b2 and b3 given system will have solution, or under what conditions on b1, b2 and b3 given system will have solution or given system will be consistent. So let's try to do this problem using Gauss elimination method. First we write down the augmented matrix corresponding to given system. So first column corresponds to coefficients of x1, which are 1, 1 and 2. Then second column for coefficients of x2, which are 1, 0 and 1. There is no x2 in second equation, so we consider coefficient of x2 to be 0, and here coefficient of x2 is 1. Third column for coefficients of x3, which are 2, 1 and 3, and last column corresponds to this b1, b2 and b3. So we convert this augmented matrix in row echelon form, and from row echelon form we will find out the conditions on b1, b2 and b3 for given system to be consistent. So to convert this in row echelon form, we start with the first non-zero entry of first row, which is 1, and we must have these two entries 0 for row echelon form. So to make these two entries 0, we multiply first row by -1 and add in second row, and we multiply first row by -2 and add in third row. So first we take this operation multiplying first row by -1 and adding in second row. So here -1 plus 1, which is 0, 1 into -1, which is -1 plus 0, so we have -1 here. Then 2 into -1, which is -2 plus 1, which is -1. b1 into -1, that is minus b1 and plus b2. So here we have minus b1 plus b2. Now we consider this operation multiplying first row by -2 and adding in third row. So -2 plus 2 0, here -2 plus 1, which is -1, 2 into -2, which is -4, and plus 3, which is -1. b1 into -2, which is -2b1 and plus b3. So now the first non-zero entry of first row is 1 and all the entries below this 1 are 0. Now we concentrate on this first non-zero entry of second row, so we must have this entry 0. So to make this entry 0, we multiply second row by -1 and add here. So third row will change. We have written first two rows as it is. Now we multiply second row by -1 and add in third row. So 0 into -1, 0 plus 0. So we have 0 here. Then -1 into -1, which is 1, and -1, 0. Same thing here, -1 into -1, 1, -1, 0. And here we multiply second row by -1. So if we multiply this by -1, we have b1 minus b2, and we have to add here, that is -2b1 plus b3. Then b1 minus 2b1, which is equal to -b1 and this minus b2 and plus b3. So this entry is minus b1 minus b2 plus b3. So if we concentrate on the last row, we can see this. From the last row we can say that if this entry is non-zero, if minus b1 minus b2 plus b3 is non-zero, then system has no solution, because if this last entry is non-zero, then the equation corresponding to last row will be 0 into x1 plus 0 into x2 plus 0 into x3 equal to minus b1 minus b2 plus b3. This is the equation corresponding to last row in row echelon form. Now if so, this is nothing but 0. So we have 0 equal to minus b1 minus b2 plus b3. Now if this quantity is non-zero, then we have 0 equal to non-zero number. So if we have this quantity minus b1 minus b2 plus b3, if this quantity is non-zero, then system has no solution. So for system to have solution, we must have this last entry, which is minus b1 minus b2 plus b3 must be 0. If minus b1 minus b2 plus b3 equal to 0, then only given system is consistent. So here we have written, which is in row echelon form. From the third row we can say that the system has a solution if and only if minus b1 minus b2 plus b3 equal to 0. This means b3 equal to b1 plus b2. So this is the condition on b1, b2 and b3 for which given system has a solution. If this condition is satisfied by b1, b2 and b3, then only given system is consistent. So hence given system is consistent if b1, b2 and b3 satisfy the condition b3 equal to b1 plus b2. So in this way we can decide the conditions on b1, b2 and b3 for which given system is consistent. We have used Gauss elimination method. So we have just converted augmented matrix in row echelon form, and from row echelon form we are able to determine the condition on b1, b2, b3 such that given system is consistent. We consider one more example of this type, example number 2, for which values of small a will the following system have no solutions, exactly one solution, or infinitely many solutions. So here we can see this is a system of 3 linear equations in 3 variables x, y and z, and in last equation coefficient of z is a square minus 14 and right hand side is a plus 2. So we don't know what is value of small a. So we have to find out that for which values of this unknown constant a system has no solution, or exactly one solution, or infinitely many solutions. So for different values of a we will have different equations in this third equation. Third equation depends on the value of a. So for different values of small a we will have different equations. So we will have different systems for different values of a. So we have to decide for which values of a system will have no solution, or infinite number of solutions, or unique solution. So again we use Gauss elimination method. We write down the augmented matrix and convert it into row echelon form, and from row echelon form we will have the idea. So first we write down the augmented matrix corresponding to given system. First column corresponds to coefficients of x, which are 1, 3 and 4. Then coefficients of y, which are 2, minus 1, 1. Then coefficients of z, which are minus 3, 5, a square minus 14. And the constants on the right hand side are written in last column, which is 4 to a plus 2. And now we start with first non-zero entry of first row, which is 1. So we make these two entries 0 to convert this augmented matrix in row echelon form. So to make this entry 0, we have to multiply first row by minus 3 and add in second row. Similarly, we multiply first row by minus 4 and add here, so that we obtain 0 here. So these are the operations which we will apply. We multiply first row by minus 3 and add here. So let's see, minus 3 plus 3 is 0. 2 into minus 3, which is minus 6, and minus 1, which is minus 7. Minus 3 into minus 3, which is 9, plus 5, that is 14. 4 into minus 3, which is minus 12, plus 2, which is minus 10. Now we multiply first row by minus 4 and add in third row. So here minus 4 plus 4, 0. 2 into minus 4, which is minus 8, and plus 1, which is minus 7. Minus 3 into minus 4, which is 12, plus a square minus 16. 12 plus a square minus 14, which is nothing but a square minus 2. And again 2 into minus 4, which is minus 8, plus we have to multiply first row by minus 4. So 4 into minus 4 and adding in third row. So this is minus 16 plus a plus 2, which is a minus 14, which we have written here. So now this is the first non-zero entry of first row. Entries below these are 0. Now we come to the first non-zero entry of second row. So we have to make this 0. So we multiply second row by minus 1 and add in third row. So third row will change. We have written first two rows as it is. Here both are 0, so we have 0 here. Minus 7 into minus 1, which is 7 minus 7, 0. 14 into minus 1, which is minus 14, plus a square minus 2. So we will have a square minus 16. Minus 10 into minus 1, which is 10. 10 plus a minus 14, which is a minus 4. So now this is in row echelon form. The first non-zero entry of third row is to the right of first non-zero entry of second row, and this is to the right of this. So this is in row echelon form. Now from row echelon form we can decide whether system has no solution or infinite number of solutions or unique solution. So we can see there are different possibilities from the last row. Suppose I have a square minus 16 equal to 0 and a minus 4 non-zero. Then I can have a square minus 16 non-zero, and a minus 4 can be 0 or it can be non-zero. There are different possibilities. A square minus 16 equal to 0, a minus 4 is non-zero. A square minus 16 is non-zero. A minus 4 can be 0 or a minus 4 can be non-zero with this. And a square minus 16 is 0 and a minus 4 is also 0. So these are the different possibilities we will consider depending on the last row in row echelon form. So we discuss these different cases one by one. and we will see what we are getting for type of solution. So from the last row we have three different cases. First case we have considered as a square minus 16 is 0 and a minus 4 is non-zero. So if this happens, then last row will be 0 0 0 and a minus 4. So if we write down the equation corresponding to last row, then it will be 0x plus 0y plus 0z equal to a minus 4, that is 0 equal to a minus 4. So now if we have this type of row in row echelon form of augmented matrix, then we will always have this type of contradiction. So that shows that given system has no solution. So if a square minus 16 is 0 and a minus 4 is non-zero, then if a minus 4 is non-zero and this is 0, then we get contradiction. This is not possible. So if a square minus 16 is 0, there are two possibilities: either a minus 4 is 0 and a plus 4 is 0. But we have a minus 4 non-zero, therefore we must have a plus 4 equal to 0. Therefore a equal to minus 4. So for a equal to minus 4, this condition is satisfied. If a equal to minus 4, a square minus 16 is 0 and a minus 4 will be minus 8. So for a equal to minus 4, we have this type of row. Last entry is non-zero and remaining entries are 0. So if a square minus 16 is 0 and a minus 4 is non-zero, we will have this type of row in the row echelon form of augmented matrix. So if we write down the equation corresponding to this row, we will have 0 equal to a minus 4. Now a minus 4 is non-zero, so we have 0 equal to non-zero, which is not possible. Therefore in this case system has no solution, and intersection of these two conditions, a square minus 16 equal to 0 and a minus 4 non-zero, is a plus 4 equal to 0. So if a plus 4 equal to 0, that is if a equal to minus 4, given system has no solution. Now we consider second case, a square minus 16 non-zero. So if a square minus 16 is non-zero, then the equation corresponding to last row will be a square minus 16z equal to a minus 4. If we consider this row echelon form, then these are the coefficients of x, y, z. So equation corresponding to last row is a square minus 16z equal to a minus 4. So if a square minus 16 is non-zero, we can divide this by a square minus 16. So for a square minus 16 not equal to 0, all the variables in this system will become leading variables. If this quantity is non-zero, then the first non-zero entry of third row corresponds to z, the first non-zero entry of second row corresponds to y, and first non-zero entry of first row corresponds to x. So if a square minus 16 is non-zero, x, y and z becomes leading variables, or there is no free variable. So for a square minus 16 not equal to 0, given system has unique solution or exactly one solution. Now a square minus 16 is 0 if a square is 16, that is if a equal to plus or minus 4, or a square minus 16 is not equal to 0 if a is not equal to plus or minus 4. So if a is not equal to plus or minus 4, given system has exactly one solution. So given system has exactly one solution for any value of a except 4 and minus 4, because for a equal to plus or minus 4, a square minus 16 becomes 0. So if a square minus 16 is non-zero, that means if a is not equal to plus or minus 4, then given system has exactly one solution. Now third case is a square minus 16 is 0 as well as a minus 4 is 0. So if we take the intersection, if a square minus 16 is 0, a equal to plus or minus 4. But as we have seen in the first case, system has no solution if a equal to minus 4. So intersection of these two conditions is a equal to 4, because a square minus 16 equal to 0 implies a equal to plus or minus 4, but system has no solution if a equal to minus 4. Therefore a must be equal to 4. So if a is 4, a square minus 16 is 0. So we can see if a square minus 16, if a equal to 4, then we will obtain zeros here. Our last row becomes 0 row. So then in that case the variable z will become free variable. If a square minus 16 is 0 and a minus 4 is 0, then the first non-zero entries of first two rows will correspond to x and y. So x and y will be leading variables, but a square minus 16 does not correspond to, a square minus 16 corresponds to z, but z is not leading variable because a square minus 16 is 0. So we obtain free variable if a square minus 16 is 0 and a minus 4 is 0, and we know that if there is at least one free variable, system has infinitely many solutions. So if a equal to 4, the last row in row echelon form becomes 0, and so the variable z becomes free variable. Therefore system has infinitely many solutions if a equal to 4. So now we can see given system has no solution if a equal to minus 4. Given system has exactly one solution if a is not equal to plus or minus 4. And given system has infinitely many solutions if value of a is 4. So sometimes they can ask you this type of problems. Here we are using the idea of Gauss elimination. So I hope you like this lecture. Thank you very much.